Hi, I'm Mark Scott from the University of Southampton. I work for the Central IT Department, and I've also got a number of authors here on the slide who are from across the university. We have the majority from the Faculty of Engineering, and we also have somebody from the library as well involved. So I'm going to talk about how the University of Southampton has started educating our postgraduates early on about the value of their data. Much of today's data relies on large-scale data sets. It was estimated in 2007 that nearly 2 zettabytes of data was produced. That's about 2 billion 1 terabyte hard drives. And by 2011, it'll be nearer to 8 zettabytes. And in fact, since 2007, we've produced more data than we can physically store. So a lot of the data is transient. So how will this data be made available to future generations, like the books and papers of previous generations? So it's important to educate researchers early on about the value of their data, and that's really what my talk is about. So the first part will show how we went about teaching our first-year postgraduates about the value of their data. We also then produced a guide to give to students introducing these concepts. So the majority of my talk will be spent going over the contents of the guide. Then I'll outline some of the lessons we learned and then finally summarise. So we really had it was a twofold approach. We produced a booklet which introduced a lot of the concepts to the students, and then we gave a lecture introducing the concepts in a lecture, and then we gave out the booklet in the lecture. The booklet itself, we spent a lot of time thinking about how to present this data and this topic. So we went for a very magazine-style layout. We tried to keep it colourful, put lots of figures in there, and to make it easy to read and digest and permit quick access to the information that we were trying to convey. This particular screenshot here is of the human genetics case study. I have the guide here. And if anyone wants to take a guide afterwards, then please come and see me. I only have about 8 or 9 of them, but if anyone's interested, please come and see me. So the guide itself was broken into 3 sections. The first section was the 5 ways to think about research data. The second section was a set of case studies, so quite similar to the previous talk, we had 5 case studies from across a number of disciplines, but what we did was we used the categories that we'd introduced in the first section to look at each discipline. And then the third section was a set of best practices, giving advice to students on how they might look after the data, looking at things like backups, version control, how they might find the data again, using tags, file names, folder structuring. And then we then started trying to get them to think about how they might access their data again in 20 years' time. EPSRC have started saying that data should be available for 10 years after the end of the project, after it's been last accessed by a third party. So this potentially 20 years is possible. And so what if the software was no longer available in 20 years? I know computing 20 years ago was a lot different to how it is now. The spreadsheet of choice was Lotus 123, for example. So we gave advice on using open standards, perhaps exporting it just to ASCII text. A lot of the formatting might be lost, but at least the valuable data would be there. So the 5 ways of thinking about data that we used, we tried to use categories that were already out there, that were well recognised. So the first one was how the data was created, perhaps from a scientific experiment or from observational data, getting someone else's data. And this was from the Research Information Network's guide on stewardship of information. I've got that Stewardship of Digital Research was the name of the publication. The second and third way of looking at data, we used the University of Edinburgh's categorisations on these topics, but we added our own and manipulated it, so we adapted those. The forms of research were things like films and photographs. That's the research that the data represents. Perhaps a musician might use a manuscript. And so that was the second way of looking at data. And the third way was how the research is represented electronically. So this was things like numerical data and text data, discipline-specific data. And we categorised that further, and I encourage you to read the guide if you want to know more. And then we looked at size and structure of the data sets and finally the data life cycle. So on to the case studies. Yesterday's keynote talks about human genetics, which I was quite pleased to see because one of the case studies that we did was human genetics. And the other 4 were from archaeology, chemistry, medicine, materials engineering and aerodynamics. So this is obviously the medicine one. We tried to use the categories that we'd introduced in the first section to then look at the data that was used in a specific example. And this gave researchers a chance to see the data used in real-world examples. So the human genetics case study, a researcher would take a DNA sample from a patient. They would then analyse the DNA using a gene sequencing machine, and that would then give them a set of data that they could then, about 50 gigabytes, that they could then analyse and tidy up. Once they've performed a process called aligning the data, that allows them to then compare it against other genetic sequences, and the human genome, as we all know, has now been mapped in its entirety. So in this case here, we have the healthy human genome on the left, and on the right, we've found a mutation. And so that was the case summary in 60 seconds. This particular case study was a great example of using reference data as a source of data. It also showed using specimens and samples as research. So not just the data we're talking about here, they have to look after the patient's DNA samples. And it also showed discipline-specific data. This data is stored as FASTQ format files. Materials engineering. This is a researcher who wants to work out how quickly a crack grows in a sample of material. So they start with the sample of material, they pass an electrical current across it. It has a crack in it, and they apply a cyclic load. They then measure the change in resistance across the crack, which then shows them how quickly the crack is growing. That data is a lot of numbers which are potential difference readings. That is imported into Excel, and they then perform smoothing algorithms on it and perhaps produce a plot like in the bottom right-hand corner. So this was a good example of a scientific experiment as a source of data, but it also showed using spreadsheets in research. And the final case study I'm going to look at today is the archaeology case study. It was a great example of using observational data as a source of data. Archaeology, by its nature, is very destructive. When they start their excavations, they're immediately destroying possible information, and so they have very strict procedures on what observational data has to be collected so they don't lose valuable information. They're very rigid at using workflows and procedures. So as part of their research, workflows and procedures is part of their research. And the final thing, this case study was a great example of using instrument-specific data, such as that coming from the laser scanner, which is in the photograph here, that is used as part of when they're surveying an area before they start their excavations. So just to finish with, I'll just evaluate our approach. The 3 sections that we used in the guide were the 5 ways to think about research data, the case studies, and then finally the best practices at the end. The first section, I think, was very, very useful as part of the booklet and allowed us to introduce types of data to the students and to get them to think about it when comparing to their own types of data. I'd say in a lecture, you've got to be very careful with this because going through lists is not exactly the most interesting thing to do, and you can spend probably an hour going through some of these lists. So that was probably the only feeling I got about that one. The second section, the case studies, they were very good at providing perspective about the topics that we'd introduced in the first section. It also encouraged the students to think about data in general, but using real-world examples. And because we picked a wide range of case studies, the students could read the case studies that they felt were most appropriate to see what sort of data was in use. And then finally, the best practices, I think, was the most useful reference material. It probably should be expanded in future versions. That's what I would like to do in future versions, is expand this section. But also in the lecture, it came across very well because when you start scaring students, they start paying attention. So I think this is also the best section for the lecture as well. So I've nearly run out of time, so I will just summarise this slide by saying we got some feedback from the lectures. The majority of the feedback from the students was positive. Interestingly, we found that it was more positive when we gave the lecture later on in the year at month 7. We feel that this might have been because students had started collecting data and were perhaps aware of the problems that could be encountered. With only 2 data points, though it's hard to draw too many conclusions. So, wrapping up, the case study approach enables diverse students to engage and relate to real-world examples. We delivered this as part of our student training for research, and it has been well received in the university, and it is now part of the university's data management plan and 10-year roadmap, and we are going to start looking. We've done this with the Faculty of Engineering, we're doing electronics and computer science this week, and we're going to start looking at other faculties as well. And I think the main point here is to get people thinking about their data and its value early. So I'm going to leave the acknowledgements on there. They're the people across the university that helped with the guide.